Welcome to Maths and Science by IITian channel. In this lecture, I will be discussing about functions and relations, the third lecture. On the topic of functions and relations, the third lecture, in which I will be discussing various functions we come across in our life, especially in sciences and mathematics. The various types of functions we come across, and they are functions like function x is equal to mod x and function x is equal to greatest integer function, and function x is equal to 1 if x is greater than 1, and function x is equal to 0 if x is equal to 0, and function x is equal to minus 1 if x is equal to less than 0. This is called as Signum function. Signum. In addition to above, we come across identity function and also constant function, polynomial function, rational function, and we will discuss one by one here. We will be discussing the functions and relations and the properties of the functions in the next class, or next or subsequent to next. In this year, different types of functions we are discussing. Usually we come across. Let us move further. We will take one by one. What is this? Function x is equal to modulus of function. Function x is equal to modulus of x. What it means? The relation is function x. Is it a function or not? Let us see. What is modulus of x? The negative value of x is positive. Modulus of minus x is equal to x. If x is greater than 0, modulus of minus x is equal to x. That is positive x. That means you give any value to x, either positive or negative, the output will be positive only. That is the modulus function. The output will be positive only. Or else we can even define it like this. Here, whatever may be the input, this is defined as function x is equal to x if x is greater than 0. It is minus x if x is less than 0. That means whatever the value of x we give greater than or equal to 0, the value of output will be positive. This implies for whatever value of x as input, please try to understand, either positive or negative, the output is equal to always positive. Except for 0, because 0 does not have positive value or negative value. That means modulus of minus 2 is equal to 2. Why it is so? Minus of minus 2, that is equal to plus 2, that is equal to 2. Modulus of 2 is equal to 2. Here also it is positive, here also it is positive. Modulus of minus 3 is equal to minus of minus 3, because minus 3 is less than 0. This will be applicable if it is less than 0. If it is equal to or greater than 0, this will be applicable. This is equal to plus 3, that is equal to 3. That means the graph of that will be input is my x value. Please try to understand. My x value is the input and function x value will be output. A cross B. In this, A is input, B is output, and this input is x and this output is function x if the relation is confirmed as the function. For different values of x, whether it is minus or plus, the output will be different, hence it is a function. Now, what can be the inputs? X value. The inputs can be minus or plus. And what will be the output? This is function x, this is x. The values on the x-axis are elements of A. The values on the y-axis are function x are elements of B. Now, if x is minus 1, function x is plus 1. If x is plus 1, function x is plus 1. The red line shows the value of function x is always positive. Whether the value of x is input is either positive or negative in the modulus function. Now, we will be doing the numericals in this. Once I define what is a function I have defined and I am taking different types of functions here, then we will be doing numericals. Wait for 1 or 2 classes. 1 or 2 lectures. Next is greatest integer function. That is, function x is equal to greatest integer of x. That means the x value, the greatest integer value. For example, x is 1.2 means the greatest integer is 1. The greatest integer function gives the greatest integer value for x less than x. Could you understand? Can you understand this? X is equal to the greatest integer value of x is the greatest integer less than or equal to x. For example, x is equal to 1.2. That implies greatest integer of 1.2. That means the value should be the greatest integer less than 1.2. What is the greatest integer less than 1.2? Is 1. If x is equal to 2.3, greatest integer less than 2.3 is 2. If x is equal to 0.9, what is the greatest integer less than 0.9? That is equal to 0. For example, x is equal to minus 0.20. Then what is the greatest integer? Minus 0.20. What is the greatest integer? Is minus 1. That means it has different values for different values of x, the integer values in form of function x. Function x will have always integer values only. It cannot have values between the integers. The function x will always be, it shows function x is always integer only. Greatest integer function. That means we'll draw the graph like this. These are all very useful graphs. Please give attention to them. This is function x. Y is equal to function x. Don't worry. In y axis we have written function x. This is x value. X value is how much? 1.2. X value, let me say it is 1.2. What is a function x value? Function x is 1 only. This is the point. Whether x is 1.2 or 1.1, the function x is 1 only. Okay. Between 1 and 2, the greatest, here let us say it is 2. Between 1 and 2, greater than 1 and up to 2. Greater than or equal to 1 and less than 2. The value of function x is 1 only. Similarly, greater than or equal to 2 and less than 3, the function x will be 2. Greater than, less than, greater than 0, greater than or equal to 0 and less than 1. Here 1. The value is 0. X value. Red line is the graph and it is minus 0.2. X is minus 0.2, less than 0 and greater than minus 1. Let us say here it is minus 1. Then the value is function x is minus 1. This is the value. That means the graph will be like this. I am drawing it again for your convenience. This is function x, like this, like this, and like this, and like this, for the values whatever we have discussed. This is the graph. That means the greatest integer means the value of that function, of that x, is such that the greatest integer to be taken less than or equal to x. If x is equal to minus 3.2, let us say, the greatest integer less than or equal to x is minus 4 is less than 3.2, minus 3.2, which implies greatest integer minus 3.2 is equal to minus 4. Are you able to follow? This is the greatest integer function. These greatest integer functions are usually used in physics, in quantum physics, and also in electricity. Sometimes the frequencies of the waves we may have to define like this. Now, next is From whatever I have written here, I am taking, and other functions also I will explain you. Signum function, because these are the functions where people usually get confused. Hence, I am taking them first. Third is Signum function. What is Signum function? Signum function says function x is equal to 1 if x is greater than 0 and 0 if x is equal to 0 and minus 1 if x is equal to minus 1, x is less than 0. For example, let me say x is equal to minus 3.2 as in the previous example. That means x is less than minus x is minus 3.2 means x is less than 0. When x is less than 0, function x is equal to minus 1. That means function minus 3.2 is equal to minus 1. It's constant. If x is equal to plus 3.2, that implies x is greater than 0. That implies function x is equal to plus 1. That means function 3.2 is equal to 1. Please try to understand this. If x is equal to 0, that implies x is equal to 0, that implies function x is equal to 0, that implies function 0 is equal to 0. That means function minus 3.2 is equal to 1, it's constant, whatever may be the value of x. In negative values, it is minus 1, sorry, it is minus 1. No, here it will be minus 1. Function 0 is equal to 0, function 3.2 is equal to 1. Now can we draw this? For drawing and plotting, I have released many lectures in mathematics. Please see them, how to draw the functions. Function x here, and I have taken x as minus 3.2, x is minus 3.2, function x is equal to minus 1, here it will be, and function 0 is equal to 0, function 3.2, here 3.2, positive 3.2, then function is equal to y is equal to 1. For whatever be the value of x less than 0, the function is like this graph. For whatever be the value of x for greater than 0, the graph is like this, function x value. And for value of 0, function 0 is equal to 0. This can also be written as for example, whatever positive values or negative values you give, because it is a x by x. The value is unit only. Here it is minus 1, here it is plus 1. That's all. That means it is x by x. Function x is equal to x by x. But if x is equal to negative, the value is negative, and if x is equal to positive, the value of function x is positive. Hence, it should be modulus value. Otherwise, x by x means negative by negative will give positive value. No, negative by negative is not positive here. Modulus x on the numerator and x should be in the denominator. The reason being, for x is equal to negative values, the function x is negative, minus 1. And for x is equal to positive values, the function x is positive, plus 1. Please try to understand this equation, why it has come. Value is unity only, but for positive values it is plus 1 function x, for negative values it is minus 1. Hence, it should have a value of positive on the numerator always. Otherwise, it is not possible to have negative values. And hence, it is written like this, and function x is equal to modulus of x by x, and function x is equal to 0, because 0 by 0 is not defined. Function x is equal to 0 when x is equal to 0. It is separately defined. Okay, at 0. That means the Signum function can be written as Signum x can be written as modulus of x by x for all values of x except for but at x is equal to 0, Signum x is equal to 0. That means function x is equal to 0. This you please remember. Now, these are the special functions which I have defined now and shown in the graphs also. If you have any doubts, please put in the comments. I will clarify your doubt. Now the question is, what are other functions? Other regular functions. For example, let me say, I am drawing a straight line. From your elementary algebra or mathematics, whatever knowledge you have, you say that y is equal to mx plus c. And for different values of m, that is slope, you have different values of y and c. That means, if y is written as function x is equal to mx plus c. It is a function. For different values of x and for the constants m and c, you have different values of function x. This can be shown as a straight line. It's a function. C is the intercept and m is the slope. This is function x and this is x. This particular line, straight line, is function x is equal to mx plus c. This is C, intercept. And m is the slope, it is a constant for the line, it is a constant. That we can even know from trigonometry that it is theta, tan theta is the slope. Now, if I say theta is equal to 45, another, just we will have practice. Tan 45 is 1. That means my slope m is equal to 1 and my intercept is 0. Let me say C is equal to 0. What happens? The straight line becomes y is equal to x. Because m is equal to 1, C is equal to 0, if you substitute y is equal to x. That means function x is equal to x. How it will be? The graph will be, why I am drawing graphs for all the functions, so that visually also you will understand what is happening. It is function x. My intercept is 0. That means C is 0. It starts from 0. And my theta is 45. That means slope is 1. That means y is equal to x. That means function x is equal to x. If x is equal to 1, y is equal to 1. If x is equal to 2, y is equal to 2. If x is equal to minus 1, y is equal to minus 1. That means it extends to negative also like this. If x is equal to minus 2, y is equal to minus 2. This is a function a straight line with unit slope and no intercept. This is a function x is equal to x. That means function x value is the value of x itself. That means it is a identity function. For an identity function, slope is equal to 1 and intercept C is equal to 0. And theta is equal to 45 degree. The angle theta with the respect to x-axis will be 45 for an identity function. This is identity function. Next, there may be chances that the value of y or function x value is always constant, irrespective of the value of x. Another is in the same straight line, let me say sixth one. If slope is equal to 0, that means m is equal to 0 and intercept C is equal to constant. What happens to that straight line? Y is equal to mx plus c. When m is equal to 0, that is equal to y is equal to c. That implies function x is equal to some constant c irrespective of the value of x. That means it will be parallel. Please try to understand why I have taken y is equal to mx plus c first, and I am explaining this. So that from y is equal to mx plus c, you can derive all this from intuition. You can understand. Intercept is there, slope is not there. When slope is not there, theta is 0. And this is the line when slope is not there. This is the line when theta is equal to 90, orthogonal. This is the line when theta is equal to 0. This is the line when theta is equal to some theta. If theta is equal to 45, m is equal to, here m is equal to 0, here m is equal to, slope is tan 90, that is infinity. Here m is equal to 0, here m is equal to tan theta. If theta is equal to 45 degree, m is equal to 1. Here the line whose slope is equal to 0 and intercept is equal to c. C is the intercept. And this type of function where for any value of x, y is not, function x is not changing, it is called as constant, let me write it, constant function. We have seen identity function, constant function, Signum function, greatest integer function, then modulus function, and there will be some polynomial. What is polynomial? Please tell me. Next is polynomial function. You are very familiar with quadratic equation, ax square plus bx plus c. Y is equal to ax square plus bx plus c. Instead of y, we write function x is equal to ax square plus bx plus c. It is a function, it's a curve with n powers of 2. If y is equal to ax cube plus bx square plus cx plus d. ABCD values are arbitrary, any value you can take. Don't worry about the values of ABCD. It's a cubic equation. If a is equal to, y is equal to ax to the power of n plus bx to the power of n minus 1 plus cx to the power of n minus 2 plus so and so up to some value d. It's a polynomial. The power of x is n. Polynomial function. If a is equal to 0, then it will be a linear function. If a is not equal to 0, in this ax square plus bx plus c, it's a quadratic equation where power is 2. That means we can find the value of function x if x is known, if it is in this form. For example, let us take one equation. Function x is equal to ax square plus bx plus c. And let's consider a typical example where c is equal to 0, b is equal to 0 and a is equal to 1. What happens? Function x is equal to x square. If function x is equal to x square, what are the values of x? X is the domain of A cross B we are finding, and x square is the range which we have discussed already, that is set B. And what is the domain? X can be from minus infinity to plus infinity on a real line. If it is a real line. And regarding real numbers, number systems, please refer to my earlier lectures. Real line, complex plane, everything I have discussed. Then x square will always be positive. Whether x is negative or positive, x square will always be positive, except where x is equal to 0, x square is equal to 0. Then the graph will look like this. It will always be above x-axis. It will not go down below x-axis. For whatever may be the value of x, it will be like this, above x-axis only. And in a polynomial, as a homework, kindly draw function x is equal to x cube. For x cube, we please draw. And there is a rational function also. If there are two functions, function x defined as functions, two functions. The conditions for definition of function I have already explained in the previous lecture. Please see it. Then the ratio of them, rational function, function x by gx by function x, that's up to you how these functions are defined. Where the gx, the denominator in rational functions, denominator should not be 0. Gx should not be equal to 0. So that the function can be defined. The value of that function can be defined. Now with this, we have understood different types of functions, and we have trigonometric functions also. Function x is equal to sin x, function x is equal to tan x, numerous functions, Dirac delta function in quantum theory, Dirac delta function, used in quantum physics, Gaussian function and normal distribution function, in probability normal distribution function, Dirac delta function is like this. The area under the curve is always unity, so that it will be like this. At any point, the area under the curve is unity. Normal distribution function is also to find the 95% significance level, usually being used in engineering, manufacturing units for 95% confidence level. These are not to scale, please don't worry about the shape. Shape is like this only, but don't worry about the exactness. These are all the different functions we come across in engineering, and in especially involving electrical technology, mechanical engineering and probability, will come across this type of functions. Now, when you multiply a function with a scalar number, all values will get multiplied. These are all things you can understand, and I want to conclude this lecture with this, and we will do some amount of numericals in the next class, numericals in next lecture. Till now in the functions we have completed on the basis of the one is lecture number 1 regarding sets, regarding relations, regarding functions and different types of functions we have defined. These concepts we will use and we will develop some practice questions. The practice questions will be definitely of a higher standard, and I prepare practice questions for you all, and I will present the practice questions and I will solve them, and some of them I will give as a homework also. If you have any doubts, please comment in the comments column. I will respond to your queries, and any doubts please comment. And with this I want to conclude this session, conclude this lecture, and thank you for listening to me. Thank you for viewing my lecture. Best of luck to everybody, and if you feel there is a value addition because of this lecture to you, kindly hype and share my video and subscribe to my channel. My channel is Maths and Science by IITian. Thank you for seeing my lecture. Thank you for listening to me. Best of luck.